All right. So the last couple ideas related to matrices, matrix operations in this particular section. First of all, now that we can multiply matrices, we can talk about how we take powers of matrices, right? So if I can talk about the matrix A cubed, and of course that's just A times A times A. Now, the tricky part about that is that we really only talk about raising a square matrix, an n by n matrix, to a power, because otherwise the number of columns and the number of rows aren't going to match up. So we really only do that with square matrices, but it's just basically repeated multiplication. And remember, multiplication, we have the associativity property, so we can, we could do it this way first, and then multiply that result times the third A, or we could, it would look like that as well, would work like that as well. Although, it's the same thing, but the associativity property works. So we can raise matrices to powers. Then we want to talk about what's called the transpose of a matrix. Pretty simple idea. So let's just take let's take a matrix like this. Okay, and so its transpose, first of all, the notation is A with a superscript T. Basically, we turn the rows into columns, and so it looks like this. And so there's sometimes when we want to work with a transpose of a matrix to do this or that, and so that's all it is. You take the rows, and they become columns now. And of course, the size switches. You go from a 3 by 2 to a 2 by 3. We have a few properties related to transposes. If you take the transpose of the transpose, you're just going to get back the original matrix. Fairly trivial, but we have some that are maybe a little less trivial. The transpose of the sum of two matrices is the sum of the transpose, like that. And then maybe the most interesting one that requires a little bit of work here is that if I take the transpose of a product, that's just equal to the product in inverse order, not inverse order, in reverse order of the transposes. So that's kind of that's one that might take a little bit of time for you to think about and see why that works. But that's what it means when we talk about the transpose of a matrix. So anyway, those are just a few last little things to clean up section 2.1.